Bong. I'm a senior at UMass Amherst. Have a dual degree in mathematics and economics, or resource economics. Yeah, I really hope. I know those of you who have been here for the whole time, this is like over 26th hour, so I know it's tough. I hope you guys can see why I'm so excited about this project. I love it. Yeah, I hope you guys end this feeling a little bit of that too.
I'm Alan Kozlowski. I'm a junior EE major at HackUMass. We also have one more person on our team, Tim Fong, who's also a UMass EE student, but he has work, so he can't be here now. So for our project, we started off not knowing what to do, but we decided to build just a car that we could move in any direction. We wanted to make it remote controlled, so we went through several different ways of doing so, but most of them were not successful. One of them was trying to use an Android app and then controlling a Bluetooth receiver on this. But yeah, Bluetooth doesn't work very well, and also we don't know how to program Android apps. So we ended up using voice on phones. So we have one phone that is hooked up to this with an audio jack, and then we have another phone that calls this phone, and you would use the touchpad on the other phone to control this car. And so for hardware, we basically just have a dual motor driver, which just has a couple of gauge bridges that control the direction that the car is moving in and the steering. And we have an audio amplifier which amplifies the signal so it can be processed.
So essentially, as Alan mentioned, every plan we had just went really, really badly. And, you know, it kind of started off as a joke, like, oh, we should just call the phone. You started to think about it, and when you look at your keypad, there's a set number of keys. So we started looking into it, and we found an algorithm, Gertzel's algorithm, that you can use to listen to an audio input and register DTMF tones. Every key has its own DTMF tone, and what you get, you gotta accept this call, what you get is essentially a remote control. You've got 12 keys, you've got it wasn't on. Okay. So, like most things, you want to turn it on. But you get this keypad, and it's a little slow because we didn't really know where we were going with this to begin with. And so we got a small little chassis to build off of, and all our phones are really big. So that's kind of a pain. But it works quite well. I'm a little hesitant to turn it because I don't want to smash it. The real thing here is that if you ask how much this project is right now, I'm assuming we have the same phone, so assuming you paid the same as I did, we're looking at over like $700 here. But in reality, you need one phone that has a battery and an aux jack, and you need another phone that uses DTMF tones. So like any phone within, like, for kids my age, like within your parents' lifetime, you can use that phone and it then becomes a remote control. We tried to get a landline to prove this to you guys. Unfortunately, those are so outdated that there was nowhere to plug it in. But in theory, you could use a landline. Not only that, because these are just general phones right now, and it just uses DTMF tones, we could use any phone in the audience right now, call this phone, and use that as the transmitter or remote control. Do you want to show? Well, if you want to come down, come on.
So that it won't
Yeah,
fly
we're
off
gonna
the
put it
table.
down so you don't destroy everything.
Okay.
Let me hang up. Yeah, so looking at it, like I said, this is a joke. We started looking into it. We knew that each key had its own tone. I heard stories about people hacking the phones from my dad, so I knew that that was like kind of a thing. I guess there's a frequency for the columns and the rows. And, oh, hold on. So the way it works is, sorry. The way it works is 1, 2, and 3 are forward, left, straight, and forward, right, but fast. And then 4, 5, and 6 are the same things, but slower. And then back and back fast.
So which way is it oriented? Just facing?
It's facing
The
you.
lights are
So
front.
back it up.
Yeah. Okay, so
If you heard that,
columns and rows have their own frequency. And we looked at Goertzel's algorithm, which is essentially a fast Fourier transform, but instead of doing it for all numbers, it limits the range we're looking for, and which reduces the overhead immensely in terms of calculation, which means it's very practical to do on something like an Arduino chip. Beyond that, it's funny because you limit yourself every time you go in. So fast Fourier transform, not everyone knows, it's like a smaller part of the web. Then Goats is the algorithm, smaller part. We finally ended up, one person had done this before, I'm not sure what the application was, but we went through their library, spent a couple hours just trying to understand what was going on. And essentially it applied Goats' algorithm in such a way that it was easy to just recognize the keys 1, 2, 3, all the way to #0. Yeah. Any questions?
Is there a power pack for the chassis, or do you power off the phone battery?
Yeah, so right now, this chassis, like I said, we didn't know where we were going, so overall it's slightly ineffective in terms of being a vehicle. It's running on 6 AA batteries. It has the original 3 on the bottom that the car ran on. It has an additional battery pack that we put on. One of the things that we found was that it would run really, really nicely for 2 minutes. And then it just started getting slow, and we're like, what did we do? What's wrong in our code? No, we just made like a battery hog and didn't know it. So yeah, it's running on 6 AA batteries. I'm pretty sure at this point, because we've used it 3 or 4 times, it's starting to run low on batteries. Any other questions?
What happens if you dial 911?
That is something we joked about and then realized was an issue. So we've been pretty careful not to do it. That's my response. We're just not going to do that.
So if I wanted to try to something like this, what would you think
To what?
to Google to try to
So
figure out
what you want to look up, the kind of math algorithm part is going to be Goats' theorem. You're going to have to play around with the spelling because I don't think that's how you pronounce it. If you want, I can write it. I have it saved on my phone. I've been trying to figure it out for the past 10 minutes. But essentially, it's like a fast Fourier transform, but limited, so you can do it on a small processor like this. Beyond that, just look into DTMF tones. Essentially, it's just every key has its own tone. So once you've set up how to translate and how to set up the Arduino to read the codes, you've just got 12 buttons that you can then program. So if we wanted to do it differently, we could have had straight back, left, right, and then horn, just yell something. There's 12 buttons that we could have done anything with. Yeah, I think I think I can see in your face, like you can kind of tell, like it's not so much that this is awesome, it's that like we've kind of stumbled on something that like has a lot of potential. You're not limited, like you can't, it's not you go around the corner and the remote control has no control. It's, you could theoretically control this from different country as long as there were cell service in both places. That being said, if you use $10 phones, then this right here is down to, how much does an Arduino chip cost?
Like $30.
So you're down to like a $50, yeah, down to a $50 little spy toy if you put another like $5 camera on it. That's if you buy all the parts from different things, if you specialize it. I'm sorry, I'm done. Any other questions?